Module 15.4, Day 2, Perpendicular bisectors of triangles. Content standard. Students will learn to prove properties of angles for a quadrilateral inscribed in a circle. Language objective. Students will work in groups to construct perpendicular bisector of triangles. Explain 2. Using property of perpendicular bisectors, you can use the circumstantial theorem, so this is a theorem from day 1, to find segment lengths in a triangle. Example 2. Segment KZ, LZ, and MZ are perpendicular bisector of triangle GHJ. Use the given information to find the length for each segment. Note that the figure is not drawn to scale. So here we know that point Z is your circumcenter. So we can say that segment XZ is equal to GZ and is equal to JZ. And also saying these are perpendicular bisector, we know that these two are congruent, and these two are congruent, and these two are congruent. So we can say that HK is equal to GK, and GM is equal to JM, and JL is equal to HL as well. Okay, so let's go over some examples. Example B, we're given that ZH is 85. So then we can write this as 85, and MZ is 13. So this is MZ is 13, and HG is 136. So from H to G, this is 136. So even before we start solving for the problem, we can conclude some of the measurement in our diagram, right? Okay, so saying HZ is 85, so then JZ is also 85, and GZ is also 85. And then we're given that from H to G is 136, so then H to K is half of that. So you take 136 divided by 2. So then each of these should be 68 and 68. Right, so from there we can answer our question. So we're looking for the segment from K to G. So from K to G, we know that it is 136 divided by 2, so then answer 68. And from Z to J, so from Z to J is this segment here, so is 85. Okay, now it's your turn. Okay, so then when you do this at home, take note. I want you guys to sketch the diagram. Okay? It doesn't have to be perfect. So the diagram is there to help you with your work. Okay, so we're given that KZ, LZ, and MZ are the perpendicular bisectors of triangle GHJ. Copy the sketch and label the given information. Use that information to find the length for each segment. Note the figure is not drawn to scale. Okay, so number 5, we're given that ZG is 65. So from Z to G is 65, and HL is 63, and ZL is 16. Right, so now even before we answer those two questions, we can label our diagram, right? So that means that JL is also 63, and JZ is also 65, and XZ is also 65. Okay, so at home, I want you guys to do the same thing. Make a sketch and label your drawing. So now we're looking for H and J. So then from H to J, that means that is from here to here. So then it's 63 plus 63. So then would be 126. And we're looking for ZJ. So from Z to J, we know that is this distance here, so it would be 65. Right, let's go on to number 6. I'm going to erase my drawing. Okay, so for number 6, we're given that ZM is 25, so we label ZM is 25, and XZ is 65, and GJ is 120, so this is 120, right? And then after that, we can label our drawing. So this is also 65, this is also 65, right? And then from G to J is 120, so each of these is 60 and 60. So from there, we can answer our question. So when we see that we're looking for from G to M, so G to M we know is 60, and from Z to G, so from Z to G is this segment here, so then it's 65. Right? Right. So now we move on to working with coordinate, finding a circumcenter on a coordinate plane. Given the vertices of a triangle, you can graph the triangle and use the graph to find the circumcenter of the triangle. Graph the triangle with a given vertice and find the circumcenter of a triangle. So R is the point of -6, 0. So here is R, -6, 0. And S is 0, 4, so that's S, 0, 4. And O is 0, 0. Right? In step 2, find equation for two perpendicular bisectors. Okay? So here we have the distance from R to O, and perpendicular bisector means half the distance. So we go 1, 2, 3, and 1, 2, 3. So we have a point here at, so x is equal to -3. So one of the equation is x equal to -3, and another perpendicular bisector. So if we start from here 1, 2, and we go down 1, 2, so this is half the distance. So then we have another one, y equal to 2. And then step 3, find the intersection. The intersection is this point here, so it's at -3 and 2. Remember that the point is always x, y. Okay, let's go on to example B. We're given the coordinate A is -1 and 5. So -1 and 5, so this point is A. And B is 5, 5. So 4, 5, 5, so that's our B. And C is 5, -1. So 5, -1, so this is our point C. So then now we can draw our triangle. Right? And find equation for two perpendicular bisectors. Well, we're looking for bisector means halfway, so then here we have 1, 2, 3, 4, 5, 6, 7. So halfway in between those, we go 1, 2, 3, and 1, 2, 3. So halfway is somewhere here. Right? So then that distance is x equal to 2.5. Okay, and here we have the distance. We have 1, 2, 3, 4, 5, 6. So halfway is 1, 2, 3. And so then we have 1, 2. So this part here. Right? So then we have my mistake. Let's change this to a y. And this is an x equal to 2. Okay, so then the point of intersection is 2 and 2.5. Right, so this is our y equal to 2.5, and this is x equal to 2. Right. Okay, so now it's your turn, but I'm going to work this out along with you guys. Graph the triangle with a given vertice and find the circumcenter of the triangle. Right, so we have a point -4 and 0. So -4 and 0 is here. So that point Q and point R at 0, 0, and point F as 0, 6. So it's here. So now we form a triangle. So we're looking for the perpendicular bisector. So halfway between Q and R is at -2. So passing through the x-axis, so x equal to -2, and halfway between R and S is 3, so this is y equal to 3, right? So then our point of congruency, or the circumcenter, is -2 and 3, right? Okay, let's try number 9. We have k at 1, 1. So then this is our k, and L is 1, 7, so that's L, and M is at 6, 1. So that's L. So now we draw our triangle, and we're looking for perpendicular bisectors. So the distance from K to L is 1, 2, 3, 4, 5. So halfway between that is here. So then we can say that this is x equal to 3.5, right? And the distance between K and L is 1, 2, 3, 4, 5, 6. So halfway is 3. So we're going through here. So then this is y equal to 4. So then your circumcenter is this point here. So it's at 3.5 and 4. Right. Okay, so now we want you to try this out on your own. Use the figure for problem 5 through 6. SV, TV, and UV are perpendicular bisector of the size of a triangle PQR. Find each length. So even before you start doing your work, we can label all of these out. Right. So if that's 17, this is 17, this is 25, and this is 24, and then these are perpendicular bisectors. So your V is your circumcenter, so this is 26, this is also 26. So for number 5, we're looking for RV. So we're looking from RV, so we know that this distance here given as 26, and TR, so we're going from T to R is 24. Okay. And for number 7, it's similar to what we just did in the first 2 examples. So, okay, so we're given the coordinate of 0, 0, 0, 5, and 5, 0. So here we can make a rough sketch. So this is our x, and this is our y. So we're given A is at 0, 0, so this is A, and B is 0, 5. So 1, 2, 3, 4, 5, so this is our B, and C is 5, 0, so 1, 2, 3, 4, 5. So this is C, so this forms our triangle. Okay, so we're looking for perpendicular bisector. So this from A to C is 5, so halfway between that. So then this gives us x equal to 2.5, and the distance from A to B is also 5, so halfway between that is so y equal to 2.5. Okay, so then this point here where the intersect is our circumcenter. So the circumcenter is 2.5 and 2.5. Right? Okay, so we want you guys to try this out on your own. Okay, so you use a graph of triangle ABC to complete problem 9 to 15. Draw a perpendicular bisector of segment BC on the graph. So from C to B we have 1, 2, 3, 4, 5, 6, 7, 8. So halfway between that is 4, so we can go over 1, 2, 3, 4. Right, so then our x is equal to 5. Okay, so then for number 10, use a midpoint formula to determine the midpoint of segment AC. So the coordinate for C is at 1, 2, and the coordinate for A is at 7, 10. And the midpoint formula is that we take 1 plus 7 divided by 2 and 2 plus 10 divided by 2. So then the midpoint would be 8 divided by 2 is 4 and 12 divided by 2 is 6. And the midpoint for AC is at 4, 6, so in this point here. Right, and then for number 10, what is the slope of the segment from A to C? Okay, so then the formula for the slope is x1 my mistake. The formula for the slope is y2 minus y1 over x2 minus x1. Okay, so then we have 10 minus 2 over 7 minus 1. So then this gives us 8 over 6, so we can reduce this to 4 over 3. Okay, so let me erase this. So then the slope is 4 over 3, and the midpoint we said was 4 and 6. And for number 11, what is the slope of a line perpendicular to AC? So this is our perpendicular line. So we say that this is x equal to 5. For number 13, use the point slope form to write the equation for the perpendicular bisector of AC. Let's go back to number 12. I think I made a mistake. This is not, we're just looking for the slope, right? So then the slope of AC is 3, 4. So then the slope of the perpendicular bisector line is be the negative reciprocal, so be negative 3 over 4. Okay, and then for number 13, use the point slope form to find the equation of the perpendicular bisector of AC. So we have a slope, so let's pick a point. So we say that C, we have a point of 1, 2. So we're looking for a point slope form. So the equation we said y minus 1 equal to negative 3 over 4 times x, y minus 2, my mistake, x minus 1. So then we can work this out. So y minus 2 equal to negative 3 over 4x. And negative times negative would be a positive 3 over 4. And to solve for it, so then y equal to negative 3 over 4x plus 3 over 4 plus 2. Right, so let me erase this so I can write the equation. So it would be y is equal to negative 3 over 4x, and 3 over 4 plus, so we can change the 2 to 8 over 4, so it gives us plus 11 over 4. Okay, so let me clean up this work. we said this is 4 over 3, so this is negative 3 over 4. And for number 14, draw the perpendicular bisector of AC. So we have, so let me do a rough sketch. We have something like this. Okay, so what is the point where the line intersect? So we say that this is x here, so they intersect at this point there. Okay, so that would be 5 and 6. Okay, so that's the end of day 2. So your assignment for today is on number 10 through 12, and you are to work on continue with your HRW. And for day 3, we will be doing construction, so we need you guys to bring in your construction, right? Okay, so for day 3, we will be working on a worksheet, and to finish your HRW and to copy down 15.1 day 1 notes.